In the first part of our project, for obtaining the area of the curve, we need first the definite integral for getting the intervals. So far, when integrating, there has always been a constant term left. For this reason, such integrals are known as definite integrals. With definite integrals, we integrate a function between 2 points, so we can find the precise value of the integral and there is no need for any unknown constant term. So, with the definite integral, we use them to get the area under the curve. The area under the curve is between these 2 points that can be found by the definite integral between them. To find the area under the curve, we make y equal fx between x equals a and x equals b. Integrate y equals fx between the limits of a and b for obtaining the given limits. The area under the curve has tons of real-life applications, like in a construction, it's used to get the area of bridges, transit curves. Curves on skate parks by far are the best examples because they are like the perfect representation of these graphical aspects. Also, the area under the curve is used for structural analysis of the building to know if they are built into not plate construction surfaces for them to get like safe construction paradigms. Also, they are used by scientists to know the volume of different waves because this curve is used for getting like the size of the tidal wave. They're used.
The first thing you need to do is identify. You need to identify three key terms. The curve, in other words, the function, and the limits, which we'll call a and b. The second step you need to do is to integrate. The function you identified will now be integrated. You're free to use the rules you already know. The final step is to substitute. With the integral you have, now you'll substitute the limits in it. Be careful with the signs. Another way to see your answer is by graphing. If you graph your function and take both limits and place them on the x-axis, the area bound by those three terms is the answer.
In conclusion, to get the area under the curve, you need to know what definite and indefinite integrals are. The definite integrals are better since we only need to integrate a function between 2 points and then we can get the exact value of the integral instead of getting unknown constant terms, like in the case of the indefinite integrals. There are several applications to use the area under the curve as mentioned in this video. You need to follow several steps in order to get the area under the curve. It's not a difficult procedure, but it's easier if you follow clearly the steps that are shown in this video. Thanks.